Okay, good afternoon, ladies and gentlemen. Time for the last talk of the day. It's Thomas Senyk from Pelagico on porting Qt to embedded hardware.
Hi, and welcome to my talk about porting Qt to embedded hardware. See a few familiar faces. Not much, so we'll start by introducing myself. My name is Thomas Senyk, graduated computer science in 2009. Then became an employee with Nokia in the Qt Professional Services engineering team, helping Qt customers with their embedded systems, getting the most out of their hardware, getting most out of their systems, porting Qt, cross-compiling Qt, helping with the hardware acceleration, helping with taking the right decisions, and so on. Since mid-2012, so nearly half a year ago, I and a few of my colleagues founded a Munich office of Pelagico, a partner we worked before with, and it's basically the same job, helping Qt customers with their embedded system projects. The only difference is that we try to focus on automotive. The host company, Pelagico, is an open source automotive stack, has that kind of focus, and we cover the Qt perspective of that business. Yeah, in my few little spare time I have, I like to go out to drink beer. I'm German, so obviously traveling, yeah, video games. So let's continue with what we're going to talk about today. This talk in general is what one consider the starter talk for cross-compiling. So we'll introduce you to all the aspects. I'm not going to go into that very deep details, but the general concepts. We'll start by explaining the basic phrases that we are all on the same page, especially sysroot and rootfs. There's some misunderstandings and some misdoings, and a lot of people doing it wrong. Sometimes not by choice, but still want to clear things up there. Then the main topic, the main part of this talk, cross-compiling Qt. What parts do we need there? What's important there? It's basically the MakeSpec and the configure line. Those two together make a cross-compile Qt. Then we have a short excursus about device MakeSpecs, where I participated in doing them, and yeah. And at the end, we will shortly talk about deploying Qt, deploy and run Qt. There isn't much to talk about there. It's basically one important thing. One question to you: who of you have been to last talk about Qt on embedded systems? Not much, it seems. Only a few. I hope all of you were there, because one part of my talk was actually overlapping. But as so little of you were there, I'm going to shortly talk about Qt plugins anyway. So yeah. Important about the talk is the perspective and the scope. My personal perspective, what I'm working at the moment, is Qt 5 and embedded Linux. That's also the perspective of this talk. So all the examples will be Linux tool examples, and the examples, the hands-on I will doing will be Qt 5 MakeSpecs. But the scope is really Qt 4 and Qt 5. Nearly all aspects except the device MakeSpecs we will hand at the end of this talk is Qt 5 is applicable for Qt 5 and Qt 4 as well. And also any supported operating system is covered by the principles and the things we're talking about here. Which is out of scope is porting to new operating systems. There are very little operating systems out there Qt hasn't run on yet, so this isn't a problem for most people, but it's out of scope of this talk. Also, porting to new windowing systems. I did a talk last year. It was recorded, and you can watch it if you're interested in porting to new windowing systems, but also out of scope of this talk. Okay, let's start with cross-compiling in general. I got a quote from Wikipedia here. It's rather long and you have to read once or twice to understand it. What it basically says, a cross-compiler is a tool which runs on one machine and generates executable binaries for another machine. Fairly easy here. Cross-compiling toolchains, they must contain a certain part of tools. The must-have is the toolchain itself, so from source code to executable binaries. The examples here, GCC, AS, and LD, they're typically Linux tools you will get with the GNU compiler set. That's why there's a GNU icon here, because that's a GNU examples, but the same principles, again, they should be applicable, and they are applicable for other type of tools and other type of operating systems as well. Good to have our additional helper tools. Mostly here, which is important, is strip. Strip is a tool which will remove all unnecessary stuff, symbols and debug information from your libraries. Nice to have our debugging and profiling tools. Debugging tools are sometimes part of the toolchain, for example, GDB. If it's part of the toolchain, the reason for that is that the GDB, which is part of the toolchain, runs on your host machine, and you can connect with that to the target where GDB server runs. And why it's good that this is part of the toolchain is because then it will probably understand all it's configured in a way that it will understand the instruction set and all the stuff coming from the board. This is the important section in that part of the talk, sysroot and rootfs. There's some misconceptions here. The proper way of doing things is the sysroot is a file system which is used during build and link time, and only for that. And for runtime, for running the board, this is not what we're talking about right now, but this is the other side of the medal. The rootfs is for the runtime only. And this should be split, and there should be two separated dedicated file systems. This is how you probably do it. There are various reasons for that. I'm not going into details right now. If you have questions about it, you can ask me later. And the tinker way of doing stuff, which happens to be more and more common, at least that's my impression, is that there is no sysroot. It's just not existing in the BSP or SDK or whatever you get. And you have to use the root file system at build and runtime. That brings problems with it, and yeah, again, not going into details, but it's problematic.
One example or something.
Yes, on the next slide.
Okay, good.
This is examples of a few build systems I work with or I know. My personal favorite at the moment, at least, is OpenGL Core, or Yocto to be specific. It's a very flexible and very powerful kind of building your root file system and your sysroot. It builds everything from scratch. That means besides some runtime dependencies for the tools themselves, it builds everything from source. So the toolchain is built from source. Then after the toolchain is built, it will start building link time dependencies and compile time dependencies into the sysroot, and you will build on the way more and more packages, and in the end create all that stuff. You will eventually create the root file system, and what you have that after that is you have a proper toolchain for your target and for your configuration. You have a proper sysroot which you can use during build and link time, and you have a proper root file system which is mirrored and which fits to the sysroot and can be used during runtime. And that's a nice way of working, and that's an engineering way of working. And yeah, the other very interesting or very positive thing about OpenGL Core is that a lot of OEMs support it, and they support their own hardware adaptation layers, it's called in OpenGL Core. And they maintain that and provide a way of easily building for their boards. One company I know of which is more involved in it and becomes more involved in that at the moment is Freescale, which has its own IMX adaptation layer. Other examples are the Beagle board or the Panda board, which have also layers to support the boards. build root is another example which is similar to OpenGL core. It's way older. It's MakeSpec based, but basically does the same thing, builds everything from scratch. Yeah. And then we come to the more problematic ones. LTIP is one of those examples. Where you have only a root file system, you don't have a file, you don't have a sysroot. It's actually the least problematic one I've seen so far, beside one other exception. The problem with LTIP was that some of the build time dependencies, POSIX build time dependencies to be specific, were part of the toolchain, and you could not use -sysroot, which is a flag --sysroot for the GCC. It's kind of very nice and convenient to use it. You can work around it, but again, at least it's a small problem you have to worry about, and which is because it's not split into between sysroot and rootfs. More problematic is the next example, and for that we got every related example as well. NVIDIA Vibrant, everything is pre-built in there, and it's Debian based. I think it's on Ubuntu. And with Ubuntu systems or with Debian based systems, you have a big problem because Debian systems have a lot of absolute file passes, either in symlinks or in linker scripts and all that kind of stuff. So absolute file passes means they begin with /, so they will reference your host libraries and they will reference to your host includes and all that stuff. And you have to work around that somehow. There's basically two ways. You either hack the file system so long that it does not contain any absolute file passes anymore. I've done that once. I will never do that again. The other way to solve the problem is to get the help from some tools. Scratchbox is an example, which is actually built for Debian to solve this particular problem. Yeah. But again, it's the think way of doing things, and if you can avoid it, if there's a chance of using a proper build system like OpenGL core or something similar, you should take that because it makes your life way easier. So that was about the basic principles about cross-compiling. Any questions there? I mean, it was a rather simple introduction. Most of you know everything I've told you just now. I would just want to be on the same page here. Yeah?
I still don't understand what the problem is when you have no sysroot.
Okay. So I will tell you two things. A practical problem is, again, if you're Debian based, then in Debian systems there are links, absolute links, so to /. So there's a link in userlib in the root file system where you have to link against because you have to link to the library during link time. And in that library is actually not a file, but it's a symlink, and it's referencing to /userlib /something, the library name. And then the GCC or to be specific, the LD will have to use or will find the host library, and he can't link to another architecture. So that's a practical problem. So that you will get an error like, I found a library here and there, but the wrong architecture or a mismatch of architecture, however the error is exactly named, and then it just breaks and stops compilation because you cannot link properly.
Yeah, but that sounds like the problem is that something is using absolute paths. Right?
Yes, that's a question if one should have absolute passes in your distributions, but Debian-based do, and all of them do. I've never seen a Debian-based image which does not have absolute passes in there. Especially the symlinks is relatively easy to solve. You can relatively easy find them, but there's also some linker scripts and stuff like that where you have that in the file, and then the problem is even worse because it's very hard to find them, and you have to configure, make, it's broken. Make again, fix, broken. And it's, again, I've done that once, I'm never gonna do it again. That's a practical problem from the engineering point of view and from the high level point of view, from the architecture point of view. The problem you're having is if you split them up, you can optimize the root file system. You can do nasty things like having absolute passes. You can work on improving the performance without having to consider that you need the same stuff during link time as well. And all that kind of, the workflow and how you handle stuff is easier if you split them to sysroot and root file system. Okay, any other question? Oh, sorry. Okay, then let's head over to the actual topic of this talk, cross-compiling Qt. The assumption here where we start is that we have what we just talked about. We have a proper cross toolchain which we can use, and we have a sysroot, or in the worst case, we have at least a root file system. So what else do we need? What do we need to put into Qt? It's MakeSpec and a configure line. Let's start with the MakeSpec. A MakeSpec is a folder which lives in as a subfolder in Qt-based MakeSpecs. The folder has to follow a certain naming scheme. This is very important because if you do not follow the naming scheme, you might end up having problems which are very, very unrelated to the actual cause of the problem. I once spent, yeah. I also spent on a system where I have not implemented the MakeSpec like a week debugging WebKit, and at the end I realized there's a configuration mismatch, and then I checked where is it set, and then in some project file he checks does the MakeSpec have a GCC in it, then I set that flags, and if not I set other flags. And he was choosing the other flags because the MakeSpec was named Linux trim instead of Linux trim-G++. So this is important to follow, and if you violate that, you will have problems. There's an official and there's a kind of unsupported naming scheme people tend to use. The official one is operating system, compiler, and then dash additional informations. Unsupported one, which I've used a lot because people told me to that this is the right one, but I recently learned that it's actually wrong, is operating system dash hardware, for example, dash Spiegelboard and then dash compiler, in that example, G++. If you start a new MakeSpec, the best thing you can do is choose next best relative. There are, if you take a look at the MakeSpec folder here, there's a lot, and you will always find some close relative. And there are various reasons for that. There's in the beginning of the MakeSpec, there's a few things which will be included and stuff. And if you start with your next best relative, you're going to have a life which is, your life is going to be easier, and you avoid problems. So what's in the folder? In the folder there are basically two files. QPlatformDev.h, it's a C++ header, which will be included by Qt Core. What the content is typically that you include another platform dev, already written one, for example, the one from Linux and G++. So it doesn't matter if it's ARM or not, this is just including stuff. So you choose already supported operating system here, which you include the platformdev.h file from. Anything else, if you feel the need of writing your own, then this means you're also writing your new port to new operating system. And again, this is out of scope of this talk. So I'm also not going to talk about this file because writing your own file here is part of writing a Qt port to a new operating system. The file we are going to talk about is qmake.conf. That's an important one. That's one you will spend a lot of time doing doing porting to new hardware. So the qmake.conf is all about setting variables. there are basically three types of variables you're going to set. The toolchain itself, so specifying the toolchain you want to use or Qt should use. Additional toolchain flags, optimization flags, fine-tuning flags, is disabling, enabling options and features for a toolchain. And the third type of flags is additional files and folders. They tend to work a little bit different. There's some badge behind to make cross-platform a little bit easier. And there's a read-only variable QtSysroot. I will explain you on the next slide. Let's head to a real example here. So this is a real example. I've put a variable here to make my life easier. This actually comes from device MakeSpec. We will talk later. But I put just here a local variable where I specify the toolchain, but without the last part of the actual tool names. So all the tools begin with that prefix, and then they, as the last part of the name, the tool name is, and that's basically what that few lines are. So here, by referencing the variable, the full path is set here, and then ends with GCC, or for the C++ compiler, G++. What's interesting here, what might be interesting to note here, Link is also the C++ compiler. That's how GNU compilers work, and I think most other compilers as well, that you trigger actually the compiler to handle all the stuff, and then he will call and use the linker in the right way. Yeah, and some other tools. Actually, I tried to find out when object copy is used. I was not able to find it. I think maybe it's not used on Linux or not at the moment. But yeah, for be complete, those are the variables we want to specify. The next type of variables, flags. This is a real example here for the Raspberry Pi. So I put here C flags and C++ flags, which are actually the same as the C flags. I'm just referencing the C flags to set the C++ flags, and they are all fine-tuning variables. I want to use ARM. I want to use vertex frame buffers. I want to use the hard float ABI. Some fine-tuning to the CPU, and some other fine-tuning and setting the ABI to some embedded stuff. I've also added a linker flag where this problem or where this flag comes from. I will show you at the end of the talk when I'm doing a short hands-on, where I show you actual real problems. The last type of flags, as in the slides mentioned, is additional files and folders, additional include dirs, additional lib dirs. Here, for example, I'm setting, if you're using OpenGL, if Qt is going to use OpenGL, yes, then he will add an additional include library. That's where the driver is basically sitting, and the includes for the driver, and some additional folders here which are used. Another typical thing is that the EGL versions of those variables, so the include for EGL is the same as the include for OpenGL, because they tend to be at the same location. Same for libs. This is actually a problem, error, I'm not sure, in the deployment in the libraries themselves. The EGL library has no link, does not link against automatically to the no link dependency to the OpenGL library, but it has unresolved symbols which are in the OpenGL library, so one must explicitly link against it. Just a side note. Yeah, those are basically the types of variables you're going to see. For full list, there's lots of variations with debug, without debug, for OpenGL, for X11, and all kinds of variables. Just take a look at the documentations. you'll find a lot there, and yeah, not going to spend time explaining all of them. The config line, the slide here is mainly for completeness. I will also show you on a real example. So let's configure. That's the right one. Open source confirmed license are just for convenience. Cross-platform is the one telling Qt, yes, here I want to cross-compile. And after that, the following argument is which MakeSpec do you want to use for that cross-compiler. And I just specified the one I've opened here. And that's the usual thing. You have two tabs. One is the MakeSpec, one is with the configure. Sysroot is something I want to explain here, and it's very convenient to use, because of various reasons. First of all, it will set up package config. Package config is a Linux concept where you have, or POSIX config concept where you have files, package config files, which help you in compiling and linking against certain libraries. And -sysroot will set up the necessary package config environment variables, so package config will be used properly and rightfully for that sysroot. And second convenient thing is it will tell the GCC to use --sysroot, and that will help the GCC to find basic build dependencies, POSIX build dependencies, basically. Yeah, and if you remember, here I'm using Qt_sysroot. That's the third convenient thing here. Whatever you pass here in the config line with -sysroot /mount will be accessible in the MakeSpec as this variable. And you can easily use that to specify additional include folders and so on. Prefix is convenient. I personally find it convenient because I can install Qt with that, and if I can install Qt, that does mean that I don't have to deploy the whole build directory. And I always install Qt, also my desktop builds. It's kind of how my workflow works, but it's kind of a personal flavor of what you want to do. -OpenGL -EGL. Let me explain you a little bit how configure itself basically works. It tries to enable everything, and how it tries that is by having something called configure tests. If they pass, so if an OpenGL configure test is compilable and linkable, then he will enable OpenGL yes. And what you're telling him here, if you pass -OpenGL yes, is I need that. And if the configure test fails, give me an error. Otherwise, he will just disable it and will not tell you. It will tell you in a list of things and you can look it up, but you will not get an error. And if, for example, if you're working on dbus, want to enable this dbus, it was never compiling, then you just pass -dbus, and the second the configure test fails, he will give you an error and you will instantly see the error and everything, and just a way of conveniently working. No PCHs, no precompiled headers. This is a bug in the toolchain in combination with the current Qt version. I think on a mailing list, somebody said it will never be fixed. Maybe not. This is a typical thing. You have an error. I had the error and I was not aware of what is going on and what it is, and I will Google it, and then okay, with this toolchain version and that combination, you cannot use precompiled headers, and you just disable them. Precompiled headers are just for improving the compile speed of Qt and Qt applications. -v is very important if you're working on that stuff we are talking about right now, because -v will give you all the configure tests we just talked about, give you the actual output and what commands he calls and everything in that regard. He will disable with the -v. Without -v, he will just hide everything. He will just tell you this configure test fails and you have no information to work with. Okay, to summarize, yes?
What about prefix install? Is that needed, or do you know the config option?
What?
There's
Prefix.
one called dash prefix dash install, which is supposed to make sure that your install only ends up in the prefix, basically, and nowhere else.
Okay. I've not used it.
If you don't
Let's look it up.
then
It can be very important if I have not used it yet. But I think I heard of, I think I saw it before.
if you knew that it was needed, or
It's probably somewhere in the top. In host prefix? Is that,
it's been removed. I haven't
could
used
be,
that.
could be. Few things have been removed. Let's grab for prefix. No, it's prefix and host prefix.
Is that a very late version? Of,
Yes,
yeah,
very late.
probably been
This
removed
week.
then.
Okay,
Okay,
question answered.
thank you.
It's not important. Okay, so summarize, to cross-compile Qt, you need a toolchain, you need a sysroot, or in worst case a root file system. You need to work on a MakeSpec and on a config line. And working on MakeSpec and config line will be a forth and back. So you will start with a MakeSpec, very simple one, with a very simple config line, and you will realize, okay, there's an error. Let's go back to the MakeSpec. I need to solve that error, and back to the config line and forth and back. If you have time at the end, I will show you that process shortly. What I've done for the Raspberry Pi, for example, what needs to be done for the Raspberry Pi. Yeah, that would be basically it about cross-compiling Qt. There isn't much. It's a lot of work and a lot of things you have to understand. But unless you work on that stuff and unless you do stuff, you won't get very far. And the whole process is time-consuming, I must admit. The documentation helps only so far. The documentation can help. The process is relatively complex, and yeah. Any questions? Anything else which is important you want to hear, which is unclear? Anything else in the talk is just additional information, which might be helpful, might not. But so far everything was basics, so to say. And yeah. So if you have questions, I would do QA now. I would like to QA now, at least for any question which is already there. Okay. I'm either incredibly good in explaining stuff, or you're all very tired. I assume the second.
Can you talk more about package config? Does that just magically work? Or?
Yes.
Yeah.
So there are two environment variables, and configure will tell you which one those are. It's the long names. Let me. And then if the sysroot or root file system is properly set up in the way POSIX or Linux has to be, so package config files are in user lib package config, and then the files. If it's done that way, and I've never seen a file system which is not, then package config works magically. Just package config. This is probably horrible to read, is it? Yes. Let's switch back to my original, is that better? Yeah. Dark is better. So package config libdir is the one he will set up. And package config sysroot dir is the second one. And that's what I meant with properly set up. He will add the sysroot and then user lib package config and sysroot user share package config as directories. If the package config files are somewhere else, you can still manually set improve and set other directories as well. Yeah, and package config sysroot is just setting it to the sysroot, so that the origin, the root of where he looks is the proper one. And yeah, package config of files, for example, libpng will have a package config, and the content of that will be where's the library, where's the header file, which additional flags do I need to link or something like that, and all information which is needed to compile stuff using that library, and then at the end link the applications and libraries. That's what package config files provide, and they do that very well. The one problem with package config is that it's never complete. For example, OpenGL drivers never have package config files. I have no clue why, but I have never seen an OpenGL.packageconfig files. So that's one of the reasons why there are specific QMake variables for OpenGL, OpenGL ES1, OpenGL ES2, because this is a typical use case. This is a typical candidate where you have to add manual information to Qt. If there would be a package config file, then this information would be in the package config file. Any other questions? Okay. Then let's have a short excursus. It's still about MakeSpecs, but a special kind of MakeSpecs, device MakeSpecs. They, first of all, they have a wiki page where you can look up what's the current status. The goals of device MakeSpecs is, so there was always the problem that a lot of people in the world sitting around making MakeSpecs, and I'm sure that for the Raspberry Pi there have been a million different MakeSpecs which have been written, and the same for the Panda board and the Beagle board and so on. So the goals were simplify MakeSpec writing. That's the first goal. That's not really achieved. It's not much easier, but it's a little bit easier with device MakeSpecs, at least in some regard. The second one is give it a proper home for upstreaming, so a proper home to contribute your MakeSpec to the Qt project. That's achieved. You can today contribute your device MakeSpecs to the Qt project. Just push it to Garrett and find somebody to approve it. And from a quality point of view and from a usage point of view, they should be ready to use. Where ready to use means somebody getting a board, for example, the Panda board, and they just grab the board, have the toolchain and the sysroot. Panda board is probably going to be a root file system only, maybe, depending on what you're using. And then they just add one config line without editing any file whatsoever, compile Qt with the config line and make, and then everything is built and everything is set up properly and everything is good. That's what I mean with ready to use. And that's actually achieved by nearly all device MakeSpecs today. Their home is in Qt-based MakeSpecs devices, so they have a separate subfolder in MakeSpecs folder. They have a naming scheme. If you remember what I've told you just a few slides ago, this is not the proper naming scheme. I must admit I'm at least partly responsible for that because I was not doing anything about it back then when we started to work on that. I've not worked in configure much regarding device MakeSpecs, so I'm not sure if it's going to be easy to rename. I mean, it's going to be easy to rename them. The question is, can I just rename them without doing anything else and they will still work? I have not time yet to look into that. It's going to be not much work, but I need some time for it. And then I hope to fix that so that they follow the proper naming scheme. Somebody on the mailing list told me he will break this naming scheme anytime he wants. He will not consider it anything official, and if he has to make a change which will break that naming scheme, the working of this naming scheme, then he will not consider at all. So yeah, we have to change that soon, I guess. This is a list of currently supported devices. I worked on the iMac6 and the Tegra 2. I used the Raspberry Pi and the BeagleBoard. And for those four, I can say they are ready to use. For the others, I can't be sure. I've not used them so far, but I heard that they are. For example, in the iMac6, I had no problems whatsoever switching between LTIP and Yocto. So I written it for LTIP, then I probably fixed it for LTIP because I had to go some workarounds there. I had to make some workarounds there, which I could solve later. And I was switching to Yocto, and it was no problem at all. So it was exactly the same MakeSpec, and no problem. There are a few characteristics, some differences, especially in the config line. The config line is the one the user will use, so there must be some difference. So as we learned, we're going to use cross-platform to choose the MakeSpec. If you choose the device MakeSpec, we use -device and then the device name. And the device name is something like on that folder iMac6. Actually, -G++ should have been removed. Sorry about that. -device Tegra 2. That would be an example of choosing a MakeSpec. Defining the cross toolchain, we learned and we've seen in the example that that's going to happen in the device MakeSpec. That's different for device MakeSpecs. Sorry. We learned that in the MakeSpec we define the cross toolchain. For device MakeSpec, this is different. For device MakeSpecs, you define the cross toolchain in the config line by passing device option and then capital cross compile and then the path, but I will show you an example shortly in the next after that slide. And then in the MakeSpec itself, this variable which you pass via configure will be used to specify the actual right variables. Sysroot and the variable to use in the MakeSpec, that's not new. The same thing applies for the normal MakeSpec, but for device MakeSpecs they are somewhat mandatory. Normal MakeSpec you don't have to use sysroot, it's optional. In device MakeSpecs it's somewhat mandatory. At least every other MakeSpec uses it. And if there's some things, there are some common files, and I think currently you could actually get without sysroot something running, but it's kind of how everybody's working in the usual way, so to say. Let's search for an example. I switch back to the other color scheme. I think it's better to use, better to read. Or is the other one better? Okay. Okay, this is actually an old one. I have a better config line for the iMac6 on my desktop, but I was not able to build Yocto or hadn't yet time to build Yocto on my notebook. So this is the old LTIP version. There are similar things. Makelibs, I will explain it when I've done with everything else to not confuse anything. So device, as I said, is the -device is the replacement for -crosscompile. We choose the iMac6. Device option to specify the crosscompile. And that variable is very interesting. It contains the full path. You don't have to do that. You can skip the path, and as Windows or a lot of people do in their workflow, set the path variable so that you just need the actual toolname. That's a matter of flavor what you prefer. I prefer to give the full path name, to not fiddle with my path variable. And if you take a look at that folder, then then there are all the tools here. which are needed. And as you see, I specified the variable, the full prefix of the tool names as well, as I did in the other MakeSpec. So this full prefix is part of the variable I'm passing, and that's important for device MakeSpecs. That's how you should. That's how you have to use device MakeSpecs. Pass the full prefix, the full configuration name of your toolchain. Again, I'm using sysroot to the LTIP root file system. I'm using prefix for easy install. I use no GCC sysroot. This is the problem I mentioned with the LTIP release, that you cannot use GCC's sysroot variable because then he will not find basic building blocks anymore. Dash debus I passed here because back then I was working on fixing debus for the LTIP release, which I gave up and switched to Yocto. And dash OpenGL I always pass, and dash we also. Any questions about device MakeSpecs? Okay.
In the configure line, you postponed explaining the libs flag, I think.
Yeah, right. Dash make libs. Thanks. Dash make libs is something I call limiter. If you configure, after configure, you will type make, and this make will build certain parts of Qt, and you can specify what you should automatically build together with that one make type thing. So you configure, you type make, and then he will build basically everything. And most of the time you don't need everything. For example, one thing you probably don't need is the examples or the demos, the configure tests, the target tools, and all that stuff. And by passing limiters, you can exclude or say you just want to build certain parts. And dash make libs is, I think, the smallest possible one, and it will only build the libs and the dependencies to build the libs. So qmake will be built because he needs qmake to build the libs, but besides that, nothing will be built. Another example of limiters would be I always forget if there's a dash between or not. No make demos or no make examples. But if I use limiter, I typically use make libs because it's the minimal possible you can do. Why would one want to exclude things from building? Time. It saves you a complete build compared to a minimal build is like something like a third of the time. So you spend 2/3 of your time.
WebKit is another big time saver.
Yes, no make WebKit is another one. Exactly, you should make dash make libs and no make WebKit. That will save you even more.
Well, it fails pretty quickly, so
WebKit?
it doesn't take so long.
Yes. And in Qt 5, WebKit was a long time a big problem, and especially in cross-compiling, it's still. Personally, I don't care that much. I don't have any concrete project which is using WebKit at the moment, so at the moment I let it just fail, as most people do, I guess, and just ignore any errors which happen in the MakeSpec module. The no make WebKit was actually not working for a while. I'm not sure if it's working at the moment.
In 4.8 it usually works.
Yeah, in 4.8 it works. In 4.8 it works perfectly. In 5 it was working at the beginning, and then for a long time it was not working at all. It was just ignoring the flag. Not sure what the current status is. I gave up passing it.
It does work now.
It does work now? Nice. Nice. Then this is fixed. Then I will use it again.
Wait, you mean you use the thing to build all the Qt modules and it works?
The configure line?
I mean, there's no. Why would you use no WebKit if you can just not compile the WebKit repository in Qt 5?
Because I always use the configure in the
top level thing.
The top level thing, yes.
Yeah, that thing never worked for me. Never.
yeah, that was a long time, and a long time I also did builds for or configure in Qt and then using QMake for all the other modules I'm needing. But now I'm using the configure which is in the main, the host git, and that's working now very, very good. And I have no problems at all anymore.
Okay, I thought everybody had given up on it.
No, it's fixed.
Okay, good.
Since 2 months, 3 months.
Okay.
And it's since then it's working flawlessly, cross-compiling and host normal compiling. Also, I can also only speak for shadow builds. I have no clue what happens in in-source builds.
No, it's fine. Shadow builds are very...
Yeah. Okay. Let's shortly talk about deploying run Qt. I told you, use prefix, install Qt, then you have easier life in deploying Qt, and Qt will be significantly smaller after you have installed it because you don't have all the building fragments lying around. So use make install. Make install destier is sometimes handy. I don't need it anymore. I've used it in the past once or twice, but it can be handy. It adds an additional prefix to whatever you've added in your prefix. But there's nothing that you can deploy to, so you shouldn't deploy to with an additional prefix on the target. It's just for installing and putting it to a specific folder. This is mainly used by package maintainers to be able to build and install into a certain directory and then use it somewhere else. There's one thing which is important, you will learn eventually, but I will tell you anyway. If you use sysroot in combination with prefix, then the installation will be split between host binaries and target binaries. So QMake, which is a host tool to build stuff, host binary will be installed into prefix you gave him, and the target binaries, so the libraries, runtime tools, and all that stuff will be installed into sysroot/prefix. So in my example, where I've put for device, I've put sysroot here, that root file system, and prefix, so it will be installed into home Senyk projects, mkspecs, and so on, rootfs, user local project Qt5, mkspecs. And then just copy, secure copy, rsync, or whatever. There are various tools to just bring it to the board or to the root file system.
Is there a way to install just one of them? Or?
One of what them?
If you don't want to install the host binaries.
That's a good question. I think no. I don't want to look it up now because it could consume more time than I want to spend on it, but I can look it up later. Just visit me on the booth and it should be relatively easy to find out. If anybody else is interested in installing only one piece, visit me at my booth.
I know there are different
MakeSpec targets, yes.
So you probably
Yes,
can
yes, that was I was expecting as well.
use just one of those.
Yeah.
I will find out, don't worry.
Okay. If you run Qt then on your hardware, then you have to from Qt 4.8 QPA build, and especially in Qt 5, there's only QPA builds, there's nothing else anymore. You have to have a windowing system plugin, a QPA plugin to run your Qt. And this is a list of the Qt 5 ones which are supported or partly supported. Last talked about this in his talk, but as not many people were there, I will shortly go over the list. Minimal is just saving files to the disk, so it will not integrate into any windowing or graphics system, just save files to the disk, PNG files. Linux frame buffer uses the Linux frame buffer to open one window, basically, one full screen window. The first two have in common that they do not support OpenGL at all. No way of enabling OpenGL there. DirectFB has OpenGL support so the DirectFB plugin will have OpenGL support if the DirectFB implementation on your system also have OpenGL support. It's possible with and without. And if the Directive B plugins enables it, depends on what the implementation looks like. ETLFS has OpenGL support. It's ETL and OpenGL plugin, or one of the simple ones. The one is minimal ETL, which is the new ETLFS. And together with kernel mode settings, those three are the simple single process OpenGL plugins. They only support not only single process, but also single surface, so no multi-surface support. One example of a typical demo people try to get running on their embedded systems, which is not working, is HelloGLES2. HelloGLES2 has widgets, and in the center it has a QGL widget. The QGL widget needs a native surface, and as there's something around it, they also need some kind of surface, and that's not working on ETLFS, minimal ETL, or kernel mode settings. If you get something working, it will be looking horrible, it will flicker, it will not display one or the other part, and so on. My recommendation is just use QtQuick, 1 or 2, doesn't matter, or QGraphics View, where you can do a lot of things, and a lot of embedded hardware products and systems and design flows are actually working quite well with ETLFS. Single process, single window is not a problem for most cases. Stay away from widgets. Widgets in OpenGL painting isn't perfect anyway. You can try it, but don't be surprised if you fail. Widgets aren't meant to be OpenGL accelerated. XCB and Wayland are examples of proper plugins into proper windowing systems. So XCB for X11. X11 is a proper windowing system, and you have all the features you need there, and everything is covered. Multi-process, OpenGL, everything covered. And same for Wayland. They're a proper windowing system. And that's the stuff you want to rely on if you're doing multi-process. Yeah, and at the bottom of the slide, there are various ways of setting the plugin, either during runtime with a flag or with environment variable, or during compile time with define. And that's just the setting default one to define. The last thing I want to talk about shortly is ETLFS hooks. They are part of the ETLFS plugin and also part of the device MakeSpec. I told you that one of the goals is that if you use the device MakeSpec, you do not want to have to edit any file whatsoever. Don't want to edit a MakeSpec, don't want to edit any plugin. But sometimes on some boards and some setups, there's some proprietary stuff to do before you can use ETL. Some initializing the graphics card with some proprietary code. And the solution for that is ETLFS hooks. Within ETLFS, the code will call in certain parts. It will call functions of a class called QETLFS hooks. And you can provide the implementation for this in your device MakeSpec by just subclassing QETLFS and implementing the virtual functions, whatever you need to do in whatever situation. There's, I think it's 8 or 9 functions, something like that. You can add functionality proprietary specific to your board, to your OpenGL driver or whatever. They are part of device MakeSpecs, and in the QMakeConf, you can set your implementation with this long variable QETLFS platform hooks sources, and then you just provide your own implementation, and it will be used when the ETLFS plugin will be built. It will also be linked to your implementation, and then he will use your implementations. I just got the sign that I'm done, and that's now time for Q&A, and I think I'm on time.
Just time for a couple of quick questions before I have to make a couple of announcements about the this evening's event. Any questions? Questions for Thomas? Hey.
Okay. I looked at the wiki page you pointed to, found some documentation, but I'm not quite sure where to find the MakeSpecs themselves.
Oh, they are upstream. They are in the Qt.
They are in the Qt source.
Yes, they're in
tree. Okay.
Qt-based MakeSpecs devices.
Thank you.
And you should not rely on better one, because I think 2 MakeSpecs have been provided since then. So in beta 2 there should be the the 2 I've worked on, the iMX6 and the Tegra, they should be part of beta 2.
Okay, well, thank you, Thomas, once again, for a great talk. I'm sure it can be.
Yeah. Thank you.